Hey guys, today we're making mazes using the recursive backtracking algorithm. Once we've generated the maze, we're just going to render it inside of Minecraft. Okay, let's begin. We start off by finding a random cell in our grid, and we can move in any direction we want, and the only rule is that we can't choose a cell that's already been visited. Eventually we'll paint ourselves into a corner, and at that point we'll backtrack along our path until we can find a cell that's not been visited. We carry on until we find ourselves in a corner again, and we backtrack again. It carries on until we have to backtrack again, and we just carry on doing this until the entire maze has been filled, like that. We'll start with a class for the maze, and that'll have a width and a height, and a constructor to initialize the width and height. We'll also have a class for each cell, which will just have an X and a Y. Our cell data will be a 3D array of booleans, and the dimensions will be the width and the height and 2 for the last dimension. If we're travelling east, then we'll set east to true, and notice we don't need one for west because there will be a cell to the west from which we can travel east, and similarly we can set north to true, and we don't need a separate boolean for south because there'll be a cell to the south to travel north. So we'll set an enum for travelling north and east, and create a function to link two cells together. To link horizontally, we'll find the cell to the west, and we'll set its east to true. And to link two cells vertically, we'll find the cell to the south, and set its north to true. We're going to start with a random cell, and create some functions to move north, south, east and west. So to move north, we'll set its y value to +1. To move south, it will be y -1. East will be x +1. And west will be x -1. Then we can create a list to hold our current path, as well as a 2D array to track which cells have been visited, and an integer to count how many cells are left to visit. And we're going to mark our current cell as visited, and create a method to find all possible moves from a given cell. So we'll create a list to hold the possible moves, and a list of directions we can move in. And just get rid of that little line there, as it annoys me. Okay, let's spin through each direction and get the new cell for that direction. Check it's within the horizontal bounds of our array, and if it's not, we'll continue. Check if it's within the vertical bounds of our array, and if it's not, we'll continue as well. And finally, check if it's been visited. If it passes all of them, we'll add it to our list of moves and return that list. Now we can create a loop and get our list of possible moves. If we have at least one move, then we'll use it and assign a random one. Otherwise, we need to backtrack, which we'll do later. So once we've got our new cell, we'll add it to our path and link the cells, and then mark it as visited, and assign it back to our current cell. In terms of backtracking, we'll create a function for this. So we'll remove the last cell from the path, and then check the last cell to see if it has any possible moves. If there is a possible move, then great, we can stop. Otherwise, we're going to remove that last cell before continuing the loop again. And we'll just return null here so it compiles. And we can call our function from our maze constructor and then continue. So finally, we're going to write a function to print to the console, and it's going to call a more generic print function, which takes a wall placement delegate as its parameter. So from here, we're going to set the background color to white and call our print function. So placing a wall at I and J, we're going to move the cursor there and then print out space. And this will have a white background color, so it should show up. Then we're going to set our console back to its default position and color, and then work on our print function. So we're going to start with a loop to print a double width top and bottom, and then a double height left and right wall as well. So now back to our main method, and we can finally construct a maze of width and height 10 and call print to console. Running that, and you'll see we'll have bounding walls for our maze. So back to our print function, and we're going to use a nested loop to print a wall on every other cell. So we can place walls in between these blocks. So to place the walls, we're going to use another nested loop. And if we can't go east, then we're going to place a wall there. And if we can't go north, then we'll place a wall there as well. So we run that. You can see we have a maze, but we'd like an entrance there and an exit there. So to do that, we'll put in some if statements when we're drawing our outer wall. And if we run that, you'll see we have an entrance but no exit, and that's because for that cell we're saying we can't go east, so it places a wall there. So in here we'll just mark that the cell can go east. And now we have an exit as well. So we're going to start by creating a brand new Minecraft world. And we're going to set a few properties for it, such as its name and its game type, and create a brand new player for it and initialize the player's position. So if we run that, you'll see we're in the middle of the ocean, which isn't good for mazes. So we're going to start by flattening chunks, and we're going to spin through each block in the chunk and start by setting some bedrock. And then some stone. And then some dirt. And then the top layer is just to be grass. Now we can call this flatten chunk function, and we're going to do it for all chunks in a -5 to 5 range. We'll create the chunk and then set a few properties just to make it a bit more efficient, and then flatten the chunk and recalculate the height map and the lightbox. Then we can save it, and we can see we have a flattened chunk to work with. Now we can render our maze, so we'll get our block manager and call our print function, and we'll place some walls on the top, and then another one above that, just so it's 2 blocks high. And there we have it, we have our maze. So we make the maze a lot bigger and run that. You should see it's going to be absolutely massive. And there we go. Hope you enjoyed the video. If you did, please hit the like button and leave any feedback in the comments. And if you want to see more videos, please subscribe.